In some texts or programs, you may see the quantities such as near or far or absolute and near and far or absolute and relative. And these quantities are just a matter of size. So let's say at address 100 I have a jump 195 instruction. And the way the instruction is encoded is like this. You have your opcode right here followed by the displacement bytes. So this is your opcode and this is your displacement bytes right here. So what the processor would do is that it would convert this the displacement bit into a value. It would flip it around so that it becomes 0.92. That's because if you keep track of where these bytes are located in memory, that's because the processor would interpret the greater addresses as being the most significant byte, followed by the lower address, which is the least significant byte. So it would jump 92 bytes away from the next address after the jump instruction. So the next address after the jump instruction is 103. So it would add the displacement with 103 to produce 195. So the jump will take you from offset 100 to 195 to offset 195, and this is a relative as well as a near jump because it does not jump out of a segment, it jumps within the segment and offset within the segment. And you could also replace the jump instruction with the call instruction. And how the call instruction would function is that it would actually push the instruction pointer following the call. So it would, let's say that your call instruction would be 3 bytes long. I don't know, 3 bytes long. 3 bytes long. So at offset 103, that's where the processor would want to return. So it's call 195 and the return address is at 103. So what the processor would do is that it would push the address 103 onto the stack. Then it would go right here. Then it would call the function. And it lets its function do its thing. Then the function would all of a sudden return back to the back to 103. And the way the return instruction works is that it would pop the address it will pop the return offset. So once we push that 103, we're going to pop it with the ret instruction to pop the return address to the instruction pointer. So that now we're going to go to 103. So let's say we have we want to restart our computer, and one way of doing that is we're going to jump to the address f 0000. And if you don't believe me, you could go to debug.com and assemble this starting from 0100, and it would restart your computer. So this is a far jump because you're jumping from whatever segment you're working with into a different segment, and it's an absolute jump because you're jumping relative. You're not jumping relative to anything, so you're just jumping to this address right here. So it's an absolute and a far jump, a far. So when you have a call followed by a segment and offset value, what's going to happen is that it would push both the code segment and the instruction pointer. Then when the function all of a sudden returns, it's going to return with this instruction, return far, and that's what's going to pop the instruction pointer register followed by the code segment register. And this is a thing I neglected in my previous video on x86 procedures. So there.